Good morning, our lovely teachers and my fellow classmates. In this video, we'll be explaining to you about silicon dioxide. But before that, let me introduce you guys to my group members. Starting with me, I'm Priscilla. We have Farel, Helena, Jemima, Priscilla, and last but not least, Mario. Now, let's dive into the topic. Now, have you ever heard of a silicon dioxide? Let me explain it to you. Silicon dioxide is a naturally occurring silicon and oxygen molecule that is primarily found in sediment. Silicolysis is a chronic respiratory disease brought on over time by fine particles silica dust from quartz rock. The primary solid forms of silica are quartz, tridymite, and cristobalite. Silicon dioxide can also be called silica, quartz, or dioxylane. The molecular weight of silicon dioxide is 60.084, and for chemical safety, this substance is an irritant and a health hazard. And this is what the structure of a silicon dioxide looks like.
Silicon dioxide role in food system. Silicon dioxide is widely used as a food additive in powder or granulated product for many reasons. First of all, encapsulate volatile liquid flavor for dry application. Second of all, prevent sticking in spray dryer to achieve better efficiencies. Silicon dioxide allows quick dispersion of dry ingredients in liquids by clinging to the food particle and keeping them from clumping. This allows powdery product to remain free-flowing and other product easy to separate.
Hey everyone, Fadil here, and I'll be explaining the principle or the mechanism of silicon dioxide in the food system. Let's get into it. So basically, silicon dioxide is an inert substance that has a tendency to absorb moisture and volatile substances. The amorphous form of silicon dioxide is known as silica gel. In general, silicon dioxide or silica are not chemical reactive in terms of using them as an anti-caking agent. The mechanism of this food additive is physical absorption of moisture rather than absorbing it. Instead of absorbing moisture into the body of the gel, moisture or water is adhered to the silica gel onto the surface of its many microscopic to nanoscopic pores. The chemical principle is that the silica gel has siliconyl groups on its surface, making it have very polar ends, also known as the hydroxyl group, that attracts water molecules to bind with the silica gel, creating hydrogen bonds.
For that reason, the combination of the microscopic pores and polar ends of silica gel allows it to absorb and store moisture. The particular reason for this is the difference of water vapor gradient between the surrounding environment and the microcavities in silica gel. The water vapor pressure inside the cavities in silica gel is lower than the surrounding environment. Thus, the moisture absorption takes place until the cavities are saturated or have gained an equilibrium. Silica gel itself is able to absorb up to 37 of its own moisture weight in food products. However, if it is exposed to enough water, some types of silica gel will pop because of the breakage of the silica spheres when contacting water.
According to the Food and Drug Administration, the amount of silicon dioxide cannot exceed 2% by weight of the dietary feed. The maximum consumption should not be more than about 10 to 30 grams a day. An excessive amount of silica consumed may lead to several health problems, including the intestinal problem, respiratory disease, and others. Two of the examples of intestinal problems are the nutrient absorption and barrier function, as well as the inflammation. Silicon dioxide nanoparticles decrease the number of intestinal microvilli, which decrease the surface area available for the nutrient absorption. Next, the exposure to silicon nanoparticles at physiologically relevant doses significantly affected the iron, zinc, glucose, and lipid nutrient absorption and barrier function in an in vitro cell culture model of the intestinal epithelium. Significant barrier function of the in vitro intestinal epithelium was lost following chronic medium and high-dose silicon dioxide exposure, and this resulted in an increase in glucose transport. Moreover, the consumption of silicon dioxide nanoparticles might activate the ASE inflammasome of intestinal epithelial cells. According to a study by Ogawa et al. 2021, the activation of ASE inflammasome can lead to the exacerbate intestinal inflammation.
So moving on to the next health effect, which is the respiratory disease, will be divided to two. First is a non-eosinophilic inflammation, and the second is pulmonary damage. So silicon dioxide nanoparticles may also be involved in the development of non-eosinophilic inflammation or non-eosinophilic asthma. This experiment from a journal was done to rats, and the occurrence may be due to the Th1-Th2 cytokine imbalance accelerated by the nanosilicon dioxide, which induces immunoglobulin E production and airway inflammation by producing Th2 cytokines such as interleukin 4, which aggravate the symptoms of OVA-induced asthma such as airway hyperresponsiveness. Next is the pulmonary damage. Excessive silicon dioxide worsens the ability of the lung surfactant, or LS, for reducing the surface tension, or in this case it will increase the surface pressure. This, together with the reduction of the fluidity of the LS film, may lead to a premature alveolar collapse and respiratory failure. So besides the mentioned like respiratory disease and intestinal disease, it will also lead to another disease such as membrane damage. So silicon dioxide can cause inflammation, fibrosis, pulmonary damage, and even DNA damage, like mentioned before. Furthermore, exposure to silicon dioxide nanoparticles increase reactive oxygen species, or ROS, levels and reduce glutathione levels. This will lead to an increase in malondialdehyde production and lactase dehydrogenase release from the cells, which indicated lipid peroxidation and membrane damage, in which this will affect the human membrane and may lead to chronic diseases.
Alright, and that is all for our presentation. Here are our peer reviews and other references that we used. Thank you so much for listening and have a great day.